Stay tuned till the end for a colossal reveal. Today, we're diving into one of the most significant breakups in Earth's history, the splitting of the supercontinent Pangaea. Around 200 million years ago, the ground beneath began to fracture, creating a massive rift that eventually spanned the entire supercontinent, filling with seawater and forming a new seaway. This new body of water connected two ancient oceans, leading to the separation of Laurasia in the north from Gondwana in the south, effectively isolating the plants and animals that inhabited each landmass. This monumental event marked a pivotal point in the evolutionary journey, as life on Earth began to diverge into two distinct branches. However, this separation wasn't destined to last forever. The subcontinent of India became a wandering messenger between these two worlds, breaking away from Gondwana and embarking on a 9,000-kilometer journey across the ocean, eventually colliding with Laurasia. This epic journey took about 35 million years, but when India finally reunited with its long-lost northern relatives, things were no longer the same. Evolution had marched on during this time, leading to significant changes in the flora and fauna. When the breakup of Pangaea began, Gondwana comprised present-day South America, Africa, India, Antarctica, and Australia. At one point, Africa, Madagascar, and India were all part of the same neighborhood. But around 120 to 100 million years ago, a rift developed, causing India and Madagascar to drift away from Africa, isolating the plants and animals of Gondwana. Then, approximately 90 million years ago, Madagascar separated from India, leaving the latter to chart its own course in isolation. Such island isolation often leads to unique evolutionary paths, much like what we see in the Galapagos Islands or Madagascar. This process, known as allopatric speciation, occurs when a physical barrier creates a separation that drives the emergence of new species. During the Cretaceous period, the isolated island of India became home to a diverse array of life forms, from frogs, lizards, and turtles to plant-eating dinosaurs like the massive Jainosaurus and meat-eating theropods like Indosuchus and Rajasaurus. There were also early mammals, such as Gondwanatheres, which resembled large rodents. But India's isolation was far from peaceful. As the subcontinent began its tectonic journey, it moved at an incredible speed, initially at around 5 centimeters per year, much faster than the average tectonic plate today. This rapid movement was due to India's unusually thin plate, only 100 kilometers thick compared to Africa's 300 kilometers. The gigantic plume of hot material that triggered Gondwana's breakup had also melted part of India's base, accelerating its movement. Around 80 million years ago, India's plate sped up even more, moving at over 14 centimeters per year, pulled by two parallel subduction zones in the Tethys Sea and along Laurasia's coast. These zones acted like two people on the same side of a tug-of-war, pulling India northward at an extraordinary rate. As India journeyed through different climates, the plants and animals on the island faced immense pressure to adapt or perish. Around 67 million years ago, India slid over the Réunion hotspot, fueled by a massive plume of magma from below. This event triggered the Deccan Traps, a series of massive volcanic eruptions that flooded the Earth's surface with lava, covering an estimated 1.5 million square kilometers, an area the size of Mongolia. This catastrophic eruption lasted 700,000 years, starting just 300,000 to 400,000 years before the asteroid impact that caused the Cretaceous-Paleogene extinction event 66 million years ago. While the Deccan Traps weren't the direct cause of the extinction, many scientists believe they played a significant role in worsening the event by releasing toxic gases and aerosols that cooled the planet temporarily before the carbon dioxide they emitted eventually warmed it up again. For life on the island of India, this period was particularly harsh. The volcanic activity and the subsequent asteroid impact led to the extinction of nearly all vertebrates on the subcontinent. The few survivors, including burrowing animals like frogs, snakes, and Sicilian, were able to escape the worst effects by retreating underground. After this mass extinction, there's a gap in the fossil record for about 10 million years, leaving paleontologists with few clues about what happened next in India. But by the Eocene epoch, around 55 million years ago, we see evidence of significant evolutionary developments in placental mammals on the island. Where did these mammals come from? One hypothesis suggests they may have originated in Gondwana and survived the extinction in India, but most scientists disagree. India had separated from Gondwana before placental mammals evolved, so the ancestors of modern Indian mammals likely migrated to the island as it neared the Asian mainland. As India approached Asia, some animals may have made their way to the island by crossing smaller islands or floating on debris. Once there, India became a hotspot for evolutionary innovation. For example, both horses and whales can trace their origins to this period in India. The evolutionary history of ungulates or hoofed mammals was long a mystery, with fossils of both even-toed and odd-toed ungulates appearing suddenly on multiple continents. But a 2014 discovery of a 54.5-million-year-old fossil of Cambatherium in India provided a crucial clue. Cambatherium was a four-legged herbivore that was an ancestor to Perissodactyla, the order of odd-toed ungulates, which includes horses and rhinoceroses. As for the even-toed ungulates or artiodactyls, which include pigs, giraffes, camels, and cetaceans, whales, and dolphins, India also played a key role in their evolution. Indohyus, a small, deer-like creature with hooves, is considered one of the ancestors of cetaceans, and its fossils have been found almost exclusively in India and Pakistan. This suggests that the transition of cetaceans from land to sea began in India during the Eocene. By 49 million years ago, cetaceans had evolved the ability to swim long distances, spreading across the world's oceans. Meanwhile, India's collision with Asia around 45 million years ago allowed for an exchange of species between the subcontinent and the mainland. This tectonic event created a burst of new species, with plants and animals migrating both into and out of India. One notable example is the dipterocarps, a family of tall trees that now dominates Southeast Asian rainforests. These trees originated in Gondwana and were carried across the sea by India, eventually spreading throughout Asia. Similarly, other animals like the blind snakes, centipedes, and Sicilian, which originated in Gondwana, survived the mass extinction and diversified in India before spreading out across Asia. The rate of species migration between India and Asia continued to increase until about 15 million years ago. India's journey across the sea was a unique event that led to the evolution of equally unique species. However, this wasn't the last time that geological forces would isolate the subcontinent. The collision with Asia also gave rise to the Himalayas, the world's tallest mountain range. Just like oceans, mountains can create barriers that isolate species, leading to further evolutionary divergence. But the story of how the Himalayas changed the world is one for another time.